Sika is one of the world's leading suppliers of construction and industrial chemicals for manufacturing and automotive markets. Established in Switzerland in 1910, in the USA since 1937, and in Canada since 1957, Sika's product lines feature high-performance concrete admixtures, specialty mortars, sealants, adhesives, damping and reinforcing materials, structural strengthening systems, industrial flooring, and membranes. With sales of over $3 billion, Sika is present in over 70 countries and has more than 10,000 employees worldwide. Sika offers value-added, innovative, integrated system solutions while being committed to the environment, safety, and people. Let's take a look at Sika's lineup of wood floor bonding products. These revolutionary adhesives, Sika Bond and Sika AccuBond, are one-component polyurethane elastic adhesives. Sika has been manufacturing one-component polyurethane since the late 60s. Basically, there are three types of adhesives used for bonding wood floors down to concrete. Mechanically fastened floors and rigid adhesives, which, when set, do not allow for any expansion and contraction of the wood floor. Large fluctuations of relative humidity will generally result in squeaking, buckling, and/or debonding of strip or plank floors. Plastic adhesives will typically allow floors to gap due to their lack of memory, will compress slightly on impact, but then permanently remain compressed without springback. Elastic adhesives, on the other hand, will allow strip and plank floors to move with the changes in relative humidity. However, the movement is drastically reduced, therefore minimizing gaps and preventing buckling and debonding. The most important elements to any successful installation are moisture control and preparation of the concrete surface. Let's review some important information about concrete. Concrete is comprised of three elements: the additives such as sand and gravel, the cement that binds them together, and water that provides the liquidizer and reaction supporter for the cement. Concrete provides high compressive strength, low tensile strength, variable permeability, and a wide range of properties based on mix design, being the water-to-cement ratio, aggregate selection, admixtures, finishing techniques, and curing. Concrete is laid wet and never totally dries out. Concrete is a porous material that allows moisture to migrate through it. Moisture in concrete starts at 100% humidity and only dries back to approximately 80%. Drying time can vary based on the microenvironment. Contrary to popular belief, concrete is not always dry after 28 days. Be aware that standards in this regard continue to change. Concrete also shrinks as it dries. This next point is important. A visual inspection cannot determine if the surface moisture content or moisture vapor transmission rate is suitable for overlayment. You must test the surface before installation. There are four common methods of testing available. The first method, Plastic Sheet Test ASTM D4263, requires taping a plastic sheet to the concrete floor and waiting 24 hours. If, when you take it up, moisture is present on the underside, you know there is moisture in the concrete. The second method, Electrical Impedance Test, employs the Tramex Moisture Meter. This instrument, when placed on concrete, will measure the amount of moisture in the upper region of the concrete slab. Any reading below 4% is acceptable. The third method, Calcium Chloride Test ASTM F1869, is used to measure the rate of moisture vapor emission from the concrete slab. An acceptable reading is 3 pounds per 1,000 square feet in 24 hours. The fourth method, Calcium Carbide Method CM, requires taking a sample from the bottom of the screed. This method is used to measure the amount of excess water in the slab and will determine the moisture content. Any reading below 2.5% is acceptable. Caution: these tests only tell the moisture condition at the time of the test. These conditions can change constantly from season to season. Therefore, Sika recommends moisture protection for all on-grade applications. Concrete gets its water several ways. One is water of convenience in the original concrete mix design that will diminish over time. Another source of water comes from outside contact with the concrete, usually from poor drainage in variable amounts, and as a result of the absence of a vapor barrier under the slab. Moisture vapor emission can be another source of problems. Moisture vapor emission is not dependent on head pressure. This condition can exist in any on-grade application. Water vapor pressure is measured as the difference in PSI between warm temperature, low humidity conditions and cooler temperatures with high humidity. The difference is the water vapor pressure. 0.084 psi continuous is acceptable. The solution to moisture problems is Sika Primer MB. This product is a moisture retarder designed for on-grade concrete slabs and is an important part of Sika's systems approach. Sika Primer MB is a low-viscosity, solvent-free moisture regulator, effective in conditions of up to 6% moisture using Tramex. MB also works well as a substrate consolidator for gypsum-based concrete and is effective on old porous concrete slabs. Sika Primer MB is also an excellent adhesion promoter for previously coated slabs. If moisture content is more than 6% or higher than 3 pounds per 1,000 square feet over 24 hours, then Sika EpoSem should be used. If this condition exists, please consult with a Sika technical representative at 1-800-933-SIKA for more information. Moisture can be a major problem, but with proper testing and the application of Sika's technologically advanced products, these problems can be averted. After you have performed the moisture test and have determined that the moisture content of the slab is acceptable, it is time to prepare the surface. Begin by removing latents or any other debris such as paint overspray and drywall mud. A floor buffer with 100 grit sandpaper can be used to assure your surface is smooth and clean. Be sure to mechanically abrade any curing or sealing compounds and sweep up the debris. Give the floor a final once-over with a vacuum to pick up any dust and smaller loose particles. If you are installing over a previously sealed slab, or if you have any doubts, perform an adhesion test to be sure you have prepared the floor properly. You are now ready to begin the installation.